Today we'll look high level e-commerce system design. This is very high level system design. We assuming already we have placed in our system. These are the functionality in e-commerce system: user service, product onboarding on e-commerce, payment service, inventory management, notification, or other services that's covering the other use cases of e-commerce system. For this session, we have functional requirement to build a user profile, product search service, product recommendation, cart service, order service. Non-functional requirement, we have availability, high available system within minimal downtime, a scalable system that can handle millions of user and products, low latency, and data consistency across the system. For high availability, that we can achieve using microservices architect style. So the advantage of here using microservices architect style, if failure in one service, the other service will be available and user can use that service. Like due to some technical issue at the application side or database side, ordered services down. So the user have now available and they can use other service like they can search the product, add the product in the cart, and product recommendation system that's can see the recommended product to the user. So we have functional requirement like user profiling. So we have a separate user service and database associated with that service, product search service, and that's database. And here product recommendation service. In product recommendation service, again we have a NoSQL database we using here. We assuming some set of data for the recommendation. There is some backend element service that's based on the user history that's analyzing and dumping the data to product recommendation system, which to the what product need to show the user. So that's we have data in the product recommendation service. The cart service, there the user adding the product they want to buy into the cart. So that's all we manage in the cart service. And here again we using NoSQL database. And the order service, again we have NoSQL database. So we we have these are the services, and in top of we have API gateway. The API gateway is the single entry point for the client. All the requests will be get routed from API gateway, and here will handle all the security related things. So we see like for the different services we have different database. The RDBS we have used for user service to keep the data, and Elastic for the search, and NoSQL for products. So the reason why we use RDMS for the user information used to be a very structured data like name, phone number, email address, and the billing address. So that's used to very structure for the all the users. So if we have data structured, so better to go with the RDBMS. And for product recommendation related to product, we keep using NoSQL database. The region like the product we have like very unstructured, that's vary from the category to category. For electronic we have a different set of specification of product, and clothes we have uh, some different set of specifications. Like we talk about the product, like the cloths, we have a size and color or variety of products, the age group, that's all we that's having uh, cloth product specification. So that's the intention to use here NoSQL for the products. Elastic is using here for the search product. Like user can the type any something like electronics, so it should system to return some electronics related product. So the elastic, the intention like elastic is giving the full search capability. So using we can uh, get the product some. It enable content based search, so allowed to query the data uh, over based on the content. So that's the intention to use elastic search for product search. Coming down to scalability, so scalability that's we can achieve adding the load balancer. The service will be behind the load balancer, and all the service depends upon the requirements and the loads will scale up and scale down the individual service. Like product search, we during the still our user searching lots of product, that time may be required to scale up the product services. That all the services are behind the load balancer, the based on upon the load of the each node, that's all handled by the load balancer. That's navigate the request to who have which service have least load, or that's all we can achieve through the load balancer. So scalability can achieve using the load balancer. Low latency, low latency, there are multiple way, or that's depend upon the application performance. So for here we adding cache mechanism to achieving uh, high low latency, or adding some CDN to serve the static content to the user. So caching mechanism, what we benefit will get like improve the performance. Like we the whatever frequently hit data that's will keep in the cache, like product already added in the card, and recommended data, a recommended product to the user, that's we can keep into the cache, so that again and again will not query to the database and return to the user. So that's we can keep in the cache, and will serve whenever user has request for that, will serve from the cache. Due to that, adding the caching mechanism, it will also reduce the database load. It will not go when user has requested, it will go first to the service and service call to the database. So network traverse time we can also reduce if we keeping in the cache, or we not going to query again and again the data in the database. So that it will also reduce the database load and handle high traffic. Whatever frequently hit data we keeping into cache, so it will always return from the cache. So it will not, during the sell time, it most of frequently hit data we giving from the cache. So that's the remaining system, get not hampered to that. So better to use the cache mechanism to achieving for low latency. For data consistency, uh, for that we can use here some message broker. So here I'm preferring to use the Kafka message broker. So it is very reliable to store the data, and maintaining through that we can maintain the data consistency across the services. So Kafka basically store messages uh, permanently in the topic to ensure data is no lost if consumer or producers fail temporary. So that's will get the benefit from message broker. So this is all we can achieve non-functional requirement like availability, scalable, low latency, data consistency. Thank you.